Welcome everyone. We are discussing combination. Today through this video, I will solve some problem using theorem of restricted combination. Combination with restriction. So, you first look at the theory. Combination language will be combination or selection. Combination of n different things. N must be different. Taking R at a time, when P particular things always excluded and always included. So we first consider always excluded. P particular things are always excluded. So total things n. So suppose P particular things are deleted at first. So keeping P particular things deleting P particular things at first, because they are excluded, we have to select R things from remaining n minus P things. So this can be done in n minus P C R ways. So this is our result. N minus P C R. You remember this theory. Now number 2, always included. So look, including P particular things at first, we have to select R minus P things, because we have taken at the beginning, we have taken P. We have to select R. So remaining selection is R minus P. So we have to select R minus P things from remaining n minus P things. So this can be done in n minus P C R minus P ways. So n minus P C R minus P ways. So this is our working tool. Now putting suitable values of n, P and R, we get we can solve practical problems. So we consider problem. Now we solve a problem using this theory. In how many ways 9 men be selected from 15 so as to always exclude 3 particular men? Number 2, include 3 particular men. So look, total number of men. So n equals to 15, and we have to select 9 at a time. So R equals to 9, and number 1, exclude 3 particular men. So P equals to 3. So you have to recall only the formula. So what will be the formula for 1. Exclude 3 particular men. So, formula is n minus p c r. So, what is n? 15 minus 3 c 9. So, 12 c 9. So, exclude 3 particular things. So, from 15%, exclude 3 things at the beginning. So, remaining is 12. From 12, you have to select 9. So, this is factorial 12 by factorial 9 into factorial 3. So, 12, 11, 10, and this is 3, 2, 1. So, this is 2. So, 2 to 0. 2 to 0. So, now case 2. So, here also same data. Look, same data. N equals to 15, R5, P3. But here include 3 particular men. So, formula is N minus P, C, R minus P. So, 12 minus 3, C, 9 minus 3. So, 12C, 6. 12C, 6. So, including 3 particular things at first, we have to select 3 already selected. So, 6 things from remaining 12 things. So, answer is 12C, 6. So, this is factorial 12, factorial 6 into factorial 6. So, expanding, we get a result. So, we need this formula only. So, very simple formula. Now, see the problem. One interesting problem of restricted combination. So, we wish to select 6 persons out of 8. But if A is chosen, then B must be chosen. In how many ways this can be done? Out of 8, you have to select 6 at a time, and there is some restriction. What is the restriction? If A is selected, then B must be selected. So, look how many cases may be. Number 1, A and B are both selected. So, according to condition, A selected, B selected. So, our condition is satisfied. So, it is problem of combination of 8 things, taking 6 at a time, when 2 particular things are always included. So, what is N? N equals to 8, R equals to 6, and P equals to 2. So, both are selected. So, formula is N minus P, C, R minus P. So, 8 minus 2, 8 minus 2, C, 6 minus 2. So, 6C4. What is 6C4? 6C4, you expand. This is factorial 6, factorial 4, factorial. So, this is 15. So, number 1 is 15. So, A and B are both selected. Number 2, A and B are both excluded. This is also possible. What is our condition? If A is selected, then B is selected. So, both may be excluded. This is one possible case. So, formula is out of 8 things, 6 are taken, 2 are always excluded. So formula is n minus p CR. So 8 minus 2 C6. So 6C6 equals to 1. And one possible case also. What is the possible case? A is selected, then B must be selected. So there is a case, B is selected, A is not selected. So case 3, B is selected, but A is not selected. B is selected, but A is not selected. A implies B, but B does not imply A according to condition. So selection of 6 in which one is included and another is excluded. That is, from B is selected, excluding A at first. So what is total? 8. So from 8 minus 1, 7, we have to select. We have to select 6 when B is always taken. So this is 7C5. Why 5? Because you have to take 6 and B is already taken. So 7C5 equals to factorial 7, factorial 5, factorial 2. So 27C5. From 7 you have to take, not 7, so look, B is selected. From 7 you have to take 6 when B is already included. So from 7, 1 is excluded, 6. So this is 6C5. Look it again. Total 8. A is not selected. So total is 7. Here total is 7. Total 7. Out of 7, you have to select 6 when B is always included. So you take B first. From 7 we are getting 6. Now you have to select total 6. 1 is already taken. So 6C5. 6C5 is 6. So total possible ways. So total ways equals to 15 plus 1 plus 6, 22. Now look it again. A and B are both selected. No confusion. So n minus p, CR minus p. So 15. A and B are both excluded. No confusion. 66. Now case 3. B is selected but A is not selected. So deleting A at first, we have to select 7. We have to select 6 from remaining 7 where B is already included. So if you take B at first, then you have to select 5 from remaining 6. So 6C5 equals to 6. So total is 21. Now this problem can be solved by alternative way also. So look, total selection. So what is the alternative? Total selection minus total selection minus A is chosen. but B is not. Because our condition is if A is chosen, then B must be chosen. So total minus this one. So total is 8C6 minus A is chosen, B is not chosen. So we have already considering this case, this is 6C5. So 8C6, factorial 8, factorial 6, factorial 2 minus 6. So 7 into 8 by 2 minus 6. So 28 minus 6, 22. You can use also this theory. It will be simple. Here it is given that if A is chosen, then B must be chosen. So we are taking total selection. A is chosen, but B is not chosen. Next, now consider the third one. So this is problem of also JEE Main. In how many ways can a committee of 3 ladies and 4 gentlemen be selected from 8 ladies and 7 gentlemen? So ladies, gentlemen, 8 ladies, 7 gentlemen. In how many ways 3 ladies and 4 gentlemen can be selected if Mr. Y, if Mrs. X refuses to serve, if Mr. Y is a member. Mrs. X refuses to serve. Mrs. X will be not a member if Mr. Y is a member. So they have enmity. So Mrs. X do not wish to serve if Mr. Y is a member. So look, just the previous one, we solved this problem by total number of committee minus number of committee in which Mrs. X and Mr. Y is a member. So, total number of committee. So, required selection equals to total number of committee minus number of committees in which Mrs. X and Mr. Y are both present. So total number of committee. This is very simple, 8C3 and 7C4 without any restriction. Minus. Now 8 ladies and Mrs. X is included. We have to take 3. Out of 8 ladies, we have to take 3 when Mrs. X included, and here Mr. Y included. So included. So 8 minus 1 C, 3 minus 1. Using this theory and into 7 minus 1 C, 4 minus 1. Total to be selected 4, 1 is already selected. So 8C3, factorial 8, factorial 3, factorial 5, factorial 7, factorial 4, factorial 3. minus 7C2 into 6C3 into 6C3. 7C2 into 6C3. Now simplify. So factorial 8, 7, 6. Factorial 5 is cancelled, 3 into 2 into 7, 6, 5, 3 into 2. So 6 cancel. This is also 6 cancel. So 56 into 30. And this is 7C2. Factorial 7 by factorial 2 into factorial 5. So 7 into 6. So this is by 2. So this is 21. And 6C3. Factorial 6, factorial 3, factorial 3. So this is 20. 1680. 1680 minus 21 into 6, 5, 4. So this is 20. So 1680 minus 420. So 16 14, and this is 56. 3 into 6, 18, 16, 1680. Now 8C3 into 7C4 minus 8 minus 1C3 minus 1, 7. So 8C3 into 7C4 and 7C2 into 6C3. Now 8C3 equals to 8 into 7 into 6 and 3 into 2. 7C, 7, 6, 5. 4 is cancelled, 3 into 2. So 56 into 35. And 7C2, 7C2, 42 by 2. So 21. So 21 and 6C3. 6C3 is factorial 6 by factorial 3 into 3. So 6, 5, 4 and 3 into 2. This is 20. This is 20. So 420 and 56 into 35. 56 into 35, 1940. 1940. 5, 3, 8, 3 into 6, 18. 18. So this is 6. 1960 minus 420. So 1540 is answer. So listen again. In how many ways can a committee of 3 ladies and 4 gentlemen be selected out of 8 ladies and 3 gentlemen? If Mrs. X refuses to serve, if Mr. Y is a member. So total number of committee minus number of committee in which both are present. So 1540 number of committees. So today, through this video, I have solved some mainly three important problem of restricted combination. These are important for board as well as competitive exam also. So thank you for today.